students, welcome back to my channel once again. How are you all doing? Hope you are doing great, right? How am I looking? I am also great by the grace of God, students. Okay, it has been so long, right? I think almost a month ago I have done a video, I remember last, and because of the busy schedules and busy college work, students, I couldn't come in front of you. I'm so sorry, apologies for that. And today I'm back again, students, with full energy and also with full josh in front of my dear beloved students. Okay, so hope you all are writing your exams great, right? So next you have the chemistry exam, students. Please prepare well and write well. All the best and my blessings to you all. Okay, so what am I going to do now in this class? I'm going to explain one of the most important reactions from the chapter or from the unit, that is carboxylic acids, and it goes by name. It's called as acidic hydrolysis of an ester. So students, kindly put the side heading in your notebooks, that is acidic hydrolysis of an ester. Okay, it's there on the board, students. Please look at the board and copy down the side heading, acidic hydrolysis of an ester. Okay, now see, look at the reaction which is written below the side heading. First of all, you should know what an ester is. The general formula of an ester is RC double bond O R dash. Look at here. I can write here also R, but in order to differentiate between the two groups, just I have mentioned it as R dash. Okay, students. So here it will be having the C double bond O group. In carboxylic acids, do you remember R C double bond OH? It will be there. Okay. Here the ester has R C double bond OR. These two R's may be alkyl groups, or one alkyl, one aryl group, or two aryl groups. Fine, students? Right. So this is the ester. Now, acidic hydrolysis of an ester. So ester on hydrolysis in the presence of an acid. Let us take concentrated H2SO4, which is called as sulfuric acid, gives corresponding, look here, R C double bond OH. Now what is this called as? Carboxylic acid. Please write down, plus corresponding alcohol, ROH. Okay, students, this is ester, this is carboxylic acid, this is alcohol. So these are the two products that we are getting on hydrolysis of an ester in the presence of an acid. Okay, so this is the reaction. Now let us go into let us look at the mechanism of this reaction. Please mark it this reaction as a very, very important reaction. So students, below comes the mechanism. Put the side heading, mechanism. Ready? Are you excited? Okay. So first, this is the ester, R C double bond O R dash. Acidic hydrolysis of an ester. So hydrolysis of an ester in the presence of an acid. Okay. So look here. First, this H plus from H2SO4. That is the acid which is being involved in this reaction. Okay. So H plus from the acid will be attracted by one of the lone pair of electrons of oxygen. Okay. So mark these two pairs of electrons on oxygen. So it will be easy for us to attract or to show how oxygen is taking up H plus using its lone pair of electrons. Okay. So RC double bond OR dash, here on the arrow you please write down H plus. Now oxygen with its lone pair of electrons attracts this H plus. So what happens? A bond will be formed between hydrogen and oxygen. I am writing up here R, C, double bond. Okay. Oxygen here oxygen, here R dash. Okay, students. Now, this H plus is being taken up by oxygen. Now, this lone pair is not there. What happened? It is being involved in the bond formation between oxygen and hydrogen. There is now only one lone pair of electrons. Okay. So, because of this, it acquires a positive charge here. Okay. So, deficiency of electrons, it acquires a positive charge here. Fine, students. Now, how does this oxygen or how is this positive charge on the head of the oxygen? This is a burden. It will be satisfied. How it is satisfied? There is a double bond between carbon and oxygen, right? So, oxygen takes up these electrons, the pi electrons towards itself. Okay. So, now C and oxygen, there is only one bond. Oxygen gets back its pair of electrons. Now, try to write down what is being formed after the shift of pi electrons towards oxygen. Put an arrow here. So, students, I am writing here R. Okay. Here C. I am writing just one below the other. Now, here a single bond, oxygen, hydrogen. Now, it has no positive charge. Okay. Right side, oxygen, R dash. Fine. Now, where will the charge go now? Positive charge. From where these pi electrons between oxygen and carbon, right? Now, carbon is deficient of electron. Look here, there are only 3 bonds. So, carbon acquires positive charge. Okay? Okay, now students, till here understood? First, H plus is taken up by oxygen. Therefore, oxygen gets positive charge and this positive charge is being satisfied by the attraction of pi electrons towards itself. Now, carbon acquires a positive charge. Okay, so next what happens? Put an arrow here. Okay, now who will help this carbon? Okay, now carbon is in utmost trouble. Fine. So, here comes into the scene, water molecule comes up. Okay. So, hydrolysis of an ester in the presence of an acid. Acid work is done. Okay. How proton from acid is being used up here. Next, here comes up the water molecule. How does this water molecule help the positively charged carbon? Here there is an oxygen, right? It has 2 lone pairs of electrons. So, it shares one of its lone pair of electrons with this carbon. So, the whole water molecule comes and attaches here near the positively charged carbon. Shall I write here, students? Write down. R, C, OH, here O, R dash. Now, here comes oxygen, hydrogen. The whole water molecule will come here, students. Now, it has only one lone pair. Again, the same thing happens here, like a positive charge is being formed on oxygen. Okay. Now, here also I am writing or I am showing the lone pairs of electrons of oxygen. So, now what is the how the problem here is being solved? Oxygen, the positive charge on oxygen, it takes up the 2 electrons between oxygen and hydrogen towards itself. Now, what happens to this hydrogen? It comes out as H plus. So, this H plus will be taken up by this oxygen with its lone pair of electrons. Once again, here a positive charge is formed on carbon. So, this positive charge will be satisfied, or the water molecule helps the positively charged carbon by sharing its lone pair of electrons. Okay. Now, the whole water molecule comes up here. That means the oxygen will be sharing its lone pair of electrons with carbon. Hence again it acquires a positive, not again, oxygen acquires a positive charge, and this positive charge is being satisfied by taking up the electrons present in between oxygen and hydrogen. Okay, now the position of this H is H plus. It will not roam somewhere in the air. This H plus will be taken up by the oxygen with its lone pair of electrons. Now write down, next put an arrow and write down what comes up next. So students, next is this one, R, COH, COH, below OH. Next is oxygen, oxygen, R dash, R dash. Okay. Now this H plus is taken up by this oxygen. So here there is a bond between oxygen and hydrogen. Now this oxygen gets a positive charge. Fine till here, understood? How this positive charge and oxygen is being satisfied? Here it takes up these two electrons towards itself. That means this bond or the electrons which are involved in the bond formation between carbon and oxygen will be taken up by oxygen. Okay. So what is coming out, students? R dash OH. What is R dash OH or ROH? It is the alcohol. Check the main reaction. The products formed in the reaction. Carboxylic acid plus alcohol. So alcohol, one of the products, is being formed at this part of the mechanism of this reaction. So put an arrow here. Next, write down here minus R dash OH. So students, here minus R dash OH. Next, what remains? R, C, OH, 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 OH. Here now these two electrons taken up by oxygen, right? So here this carbon gets positive charge. Fine. Now next, this positive charge on carbon, how is it satisfied? Again there is a oxygen here, okay, with the helping hand. It shares one of its lone pair of electrons with carbon. So these two electrons will be shifted this side, thereby there will be a double bond between carbon and oxygen. So write down here RC double bond OH, here OH. So students, next I have written here because of no place here, okay, kindly please adjust with me. RC double bond OH, here OH. Fine. Now there is no positive charge on carbon here. Okay. So, but the positive charge is formed on oxygen. Okay. So this positive charge will be satisfied like this. So oxygen and hydrogen separately write the bond, and these two electrons will be taken up by oxygen, and H comes out as H plus. In the beginning it is added, at the end it is coming out. So in the presence of an acid, this reaction is taking place. So in the beginning H plus was added, and now it has come out. So the final product is RC double bond OH. This is the carboxylic acid, and here this is the alcohol. So these are the two products forming in acidic hydrolysis of an ester. Okay. So it might be a little bit confused or complicated. Okay. But second time, third time, fourth time, you will be masters, right? You can also write down without seeing on the paper. Hope you have enjoyed this mechanism, right students? Hope I made it clear. Okay, have you noted down all the steps carefully? Also one more thing students, while writing the arrows carefully, show where the pair of electrons is going, or where the atoms are being shifted. Okay, so note down students. So students, this is all for this class or this video. So stay home, stay safe, take care, and also write well your exam students, right? We'll meet in the next video with another new topic. Until then, take care. Bye-bye. Signing off, yours, Afia ma'am.